Good to go. All right.
Are we good? We're live?
I believe so.
Fantastic.
Cheryl will jump up and down and wave her arms if we're not. So.
All right. Awesome. Oh, she heard that. Cool. All right. All right. Let's get started. Hello, everybody. Thanks for coming out on this beautiful evening. Great that you could come live. I know we're also live casting this across a few time zones. Before I get started, I'm just going to do a bit of housekeeping. Then we'll do some introductions and walk you through our presentation. And hopefully the demo works. There's always a question. There we go. All right. So as we get started, I'm Mike Holland. I'm a solutions architect for the NGINX business unit at F5. So I focus primarily on our modern apps section, which NGINX is a part of. And then joined with me today is...
I am Sean Moritz, and sorry, there's no actual audio coming out of these speakers, but it's for our attendees. So yeah, I'm Sean Moritz. I'm actually former NGINX. Joined Grafana about 5 months ago, 4.5, 5 months ago. And I thought it would be a great opportunity for us to talk about how our technologies work so well together.
Every morning he wakes up regretting that decision too. He wishes he still worked with me. So he wouldn't tell you. And yep, so I just say the photo, I did that myself. This is recent, so I felt the need to draw that in. All right, so the housekeeping stuff that I mentioned. So this meeting is being recorded. And so when you guys are yelling at me that I'm not talking loud enough, that's all going to be on there for the next one. It'll be a link will come out for the recording here in the next week. So for those of you who put your wrong email address in, you're really going to regret that. And then, yeah, so the recordings and slides next week. We got virtual attendees. We have a live in-person meetup, of course, here, also in Singapore. So we have a few of our co-workers and friends in Singapore live. They're represented by the second camera down. Oh, yeah, see? Somebody standing there. I don't know why there's a background on there, but there's quite a few people in that room as well. So if you have any questions, of course, if you're live in the room, you want to ask questions, go ahead and ask them, raise your hand. If you're on the virtual session, please use the Q&A box to put your questions in there. And then when we come to a pause, we'll have a review of those and we can answer them for everybody. Any questions? No? All right. Cool. All right. So I'm going to start the first section, of course, on NGINX, and then Sean's going to take over on the Grafana. And hopefully by the end, you're going to see how amazing our two open source products work together. So that's the goal. See how we do. So NGINX started out as a solution to the C10K problem. So back in the late 2010s, 2000s, early 2000s, there was a problem where software couldn't maintain more than 10,000 concurrent connections at the same time. A lot of software was thread-based. So every connection meant a new thread, and operating systems can handle that many threads. So our founder, Igor Sisov, came out with an idea to do more event-driven architecture, using processes to handle multiple connections at the same time, and then using events to determine when those processes needed to be maintained or updated. And that allowed us to grow those connections out to beyond 10,000 concurrent connections. So of course, NGINX open source was released in 2003. Today's presentation is all open source, so we're not, the only time I'll mention commercial is this next line here. Plus was released in 2011. That's a commercial offering. And that's when NGINX became a commercial entity. Of course, we were acquired by F5 in 2019. The name was changed. I should have updated the slide. It's now just F5, not F5 Networks. But as far as NGINX adoption, you can see down at the bottom, NGINX is 33.6% of all web services. So that's a recent survey from June. So it's quite popular across the internet. It's overtaken Apache. It's overtaken all the other web servers you might think of. So it's been quite a popular and quite well adopted web server. I think a lot of your public cloud offerings today, you'll often find out that it is an open source offering that's behind those web server offerings. And oftentimes it's NGINX open source. NGINX open source ingress controller 1.0 was released in 2017. We had a couple beta releases in 2016, and that's mainly what we're going to talk about today. So we are going to focus our demo in a Kubernetes environment. So ingress controller is important. It's also the #1 most downloaded Docker container available today. So if you think about it, if you've ever done like quick starts for another company, oftentimes if you're doing like a Kubernetes demo or some type of website demo, they'll get you to install NGINX. So it's quite popular. And funny enough, I know when I'm chatting with friends and stuff, and they always ask me, "Oh, where do you work?" You know, I always say NGINX, and they always go like, "Where?" And I'm like, "Really? Where?" It's, you know, #1 web server. All the websites use it. And I look them dead in the eye, and I say to them, I say, "You know all those websites you go to?" And I just pause because they're always like worried, like, "What websites do you know?" And then I say, "You're welcome." Right. So that's how I introduce NGINX. So yeah, cool. All right. So there we go. All right. So as far as the use cases that NGINX open source can do, we do have quite a few. The web server, of course, is the most common for open source offering. But with that solution for the C10K problem that Igor found, we moved into reverse proxy, load balancing, and caching, being the next use cases there. We're also very popular for API gateway. So I mentioned those public clouds that use us for web server solutions. There's also API gateway solutions. So there's a lot of popular API gateway and API management solutions that you may be familiar with that are built on top of NGINX open source. Kubernetes ingress controller, I'm going to talk a whole heap about that in the next slide. But we do have an open source offering as well as a commercial offering with that. And then service mesh, being one of our newer offerings, isn't quite open source, but it is free. So, so it does have that model. Of course, some of the popular things with our software and open source software is that we work in multiple environments, right? So we're open source as well as operating system agnostic, public cloud agnostic. We can work in any of those environments. So the ingress controller. So today, of course, we're going to talk about ingress controller. I mentioned the open source edition and the plus edition. There's one more. So the Kubernetes communities forked are open source, and they have another one that they also do, which is based on open source. So the ingress controller is responsible for that north-south traffic entering and exiting your Kubernetes cluster. So it plays a critical role as far as publishing your applications and your services in your Kubernetes environment to your customers, right? To your end browsers, to your APIs. And so it plays that role. The NGINX Kubernetes ingress controller is deployed as a pod. We're going to go on a bit of a demo on the ways that we can deploy that. And in that environment, and with our demo environment today, we've deployed our ingress controller pods, and we decided to use a Google Cloud environment to deploy those. So of course, with all those pods, we have to have an external load balancer represented here with the black logo. In our Google environment, Google's network load balancer provides that facility for us. And what that does is it allows us to scale out and in our Kubernetes ingress controller pods to handle traffic requirements, resource requirements for your application. A lot of customers use this, open source users use this feature to keep their costs down. So if they're using a public cloud environment, you know, maybe they're busy at lunchtime, maybe there's very little traffic coming in at night, and they're able to scale in and out these pods rather quickly. So we often talk about that shift left, where we put all the smarts of our application into these pod environments that can scale out and in sub-second, right? So based on those traffic requirements. All right, so some of the more common use cases that we see in an ingress controller. So we have them listed here. So conditional routing, so based on maybe your host name, maybe your URL path. Split routing, so in microservices environments, you may have one microservice that is for, you know, / transactions in your URL. You may have one for / deposits, and we're able to route those. So split routing between those devices or between those microservices. Error pages, so if your application responds with an error page, we can handle that. So we can submit your request to another backend, another upstream, based on those error responses. Rate limiting is one I'll show in the demo, but being able to control the amount of requests per second that people are making for your websites. Authentication, so we have a limited set of authentication, HTTP basic auth, a little bit of JOT validation in our ingress controller. The web app firewall, I should have deleted it, not an open source offering, but it does work on a commercial offering. So that's all I'll say about that. And then NGINX snippets is a good one. You can't see it there, but they're looking at me in the camera here making faces. Hey, Rob. So yeah, so NGINX snippets, just as you know, as Kubernetes came up, you know, we had objects defined. You know, there's standard community objects like deployments, services, ingress objects. And as that were released and Kubernetes started growing in popularity, when you chose a vendor-specific offering, say the NGINX Kubernetes Ingress Controller, there's a lot of features and functionality available in that offering that may not be available in other vendors' offerings. So you needed a way to expose those offerings. So originally, we exposed those with, sorry, I'll just jump back over. We exposed those with annotations, right? And I'll show you examples of these in the demos, but we had annotations where you put little lines of code that we defined that would add, say, rate limiting, add policies, add different directives that are available in our specific features of our NGINX Kubernetes Ingress controller. But that didn't scale very well. And you'll see in the demo when I show, one use case, how all of a sudden you've got 3, 20, 100 annotations in there, and you start worrying about order, how they're implemented, who's conflicting with who. And so our solution to that with it in-house within NGINX was NGINX snippets. So instead of having a bunch of annotations for a bunch of different configurations, you could have one annotation that then lets you free form that NGINX.conf configuration. So that was our way of working around that. But as users quickly realized, that didn't scale very well as well. So the Kubernetes community came together and they said, okay, well, let's create something that's more user-friendly, more administrative-friendly, more easier to read and understand. And that's where the Kubernetes community came out with custom resource definitions. So we took that opportunity to use custom resource definitions and define those for all of those features and functions that are specific to our NGINX Kubernetes Ingress controller. So you'll see, all right, thanks, Cheryl. You can see here that I'm running out of time though, so I don't know if I can slow down that much. All right. I talk a lot, so I got to talk faster so I can get everything I want to say in. So we have custom resource definitions. So we have an example here of a virtual server and a virtual server route. What that allows us to do is take all the common configurations that you see in the Ingress object and add policies, for example, for things like rate limiting or job validation, access control, mutual TLS, to again, bring those features that aren't common in a lot of Ingress controllers out. So one thing that NGINX's Kubernetes Ingress controller does that a lot of others don't is we support TCP and UDP streams. A lot of them support just web applications, so HTTP, HTTPS, but we support TCP and UDP streams. And as more people start putting databases in their Kubernetes environments, we see a lot of people asking for TCP and UDP streams to support those databases in their Kubernetes environment. So, of course, a common Ingress object wouldn't be able to handle that. They're primarily built just for HTTP, HTTPS web traffic. So we're able to add custom resource definitions for what we call transport service to add TCP and UDP traffic. Another popular function of our custom resource definitions is the ability to break out the policy into different pieces. And we've seen a lot of popularity with this around companies that are broken down into different personas. I can't see the clock. Am I way over yet or am I way under?
6:13.
6:13. All right, so I got 2 minutes. 2 minutes, awesome. I'm gonna go over just keep your phone. All right, so yes, we'll break it up into pieces, meaning that you could have the security team looking at WAF policies, you could have security team looking at rate limiting, you could have the web developer team looking at upstream configurations. So you're able to break those pieces out, which is a real nice option there. All right, so this is the part where I would jump to the Grafana Labs, but I've actually got a little demo. We're going to do a little bit snippets here, so I'm going to jump to that. Sorry, Cheryl. This is where I'm going over. All right, cool. So I just want to show that with NGINX open source Kubernetes Ingress controller, we've got a lot of great examples, right? We've got a GitHub page not only has the deployment manifest, the Helm charts that you would use to deploy your open source Kubernetes Ingress controller, but also some nice examples. And we're going to go through in a second, but for custom resource definitions, so I talked about the CRDs, we can look at default Ingress resources with annotation examples, and then shared examples where we mix and match the two together. So I just wanted to highlight that. We also have some great documentation. So docs.nginx.com also walks you through how to use those manifests, how to use those Helm charts, how to modify them for your particular use case to deploy your NGINX Ingress controller. So I mentioned before, we're going to go through a couple of the configuration options here. And this first one is a standard Kubernetes community deployment document, right? So this is the deployment document we use to deploy our NGINX ingress controller. So as we go through here, I just want to highlight a few things because they'll play into our next demonstration here. As we go through, we can see that this deployment defaults to one replica. So that'll make sense a bit later. We also have a few annotations in this deployment document that expose Prometheus. So we use Prometheus to expose metrics. And if you haven't worked it out, that's the rest of the presentation there. So that's important that we show that. And you can see the container that we pull here. So this NGINX ingress version 2.3.0 is actually hosted in Docker Hub, right? So you can pull it down. We have pre-built Kubernetes ingress controllers, as well as you can build your own. So again, it's open source. You can pull the source code, you can compile it, you can add whatever features and functionality you want into it as you build it, or if you just want a demo and you want to pull down one of the pre-builts, like I've done here, you can do that as well. We've also defined in here a few ports that we want to be listening at. So the standard ports 80 and 443. We've also got an 8081. It's a readiness port that Kubernetes uses to determine that we're available and ready to start taking traffic. And then we've also got that Prometheus port exposed, and we'll see a bit more of that as we go. So just as we jump down here, there's all this standard Kubernetes deployment stuff. I just want to highlight the arguments down at the bottom, because this is where we're able to expose a lot of those additional features and functionality in our NGINX Kubernetes ingress controller. So a few examples here that I've exposed. You see there's a tag there to define a config map for our standard NGINX configuration that we want to apply globally to the pods. We've got a default TLS certificate. So if we don't define one for a TLS service, it'll automatically add one for you. So that helps avoid any errors you might get when you're troubleshooting. You can see a few other things here for enabling external DNS. And we also have one here for enabling Prometheus metrics. So this opens that endpoint up and allows those metrics to be exposed. As we jump to the next one here, so I mentioned how we progressed from ingress objects to annotations to custom resource definitions. So we can see an example here of an ingress object, right? So with this ingress object, we have our standard details that you'd expect to see there around host name, TLS certificate. I don't know if you guys can hear that, but the rain is absolutely coming down in Sydney. Yeah, so we can define also the paths. So in the application, our demo application we're going to use today is our cafe app. So we've got a microservice that serves tea, and we've got a microservice that serves coffee. So we've defined those as different services within this ingress definition. But say, for instance, you wanted to add a feature like rate limiting, right? You wanted to turn rate limiting on, you wanted to set a limit rate, you want to set it a burst. You can see how annotations here at the top, that's 3 separate annotation entries. And that's just a very basic rate limiting configuration as an example. So as that starts to grow, you're looking at an annotation for each specific thing that you want to turn on in your rate limiting. So again, with that example growing to the next one, we move into our custom resource definition, where we've now taken, instead of a deployment, or sorry, an ingress object, we have a virtual server object that's been defined here. And you can see it's pretty similar to the ingress object you saw in the previous 2 demonstrations. But this one here has a policy option. This is where we're able to break out that configuration into a separate policy. So remember, I talked about the personas, breaking it out into different groups. We're able to break that out and then define our rate limiting configuration for this example, as well as others, in a much simpler, easy to consume way. And permissions for this file could be set for a different persona. So that's how we deploy that with our custom resource definition. So if I go to our demo Kubernetes environment, you can see here that I've gone through and I've already deployed our coffee app because I knew I'd run over time. And I've deployed our T app. So we've got several services in the back we can load balance. I went ahead and put Prometheus in there as well. So deployed that via home chart. I've also went ahead in our environment and deployed the services required for our NGINX ingress controller to start up. So things like a dedicated namespace, a service account, a role, cluster role bindings, things like that have already been deployed to make sure that our service can stand up Our config map's already been deployed. Our schema sets for our custom resource definitions already been deployed. Again, this can all be deployed very quickly with a Helm chart, but I did it in pieces so that I could show a bit of a demo today. So the first thing we do is you saw that deployment document that I did, and if I just apply that, we can, what was it? Yep. We just apply, this would be the ingress controller. So that same deployment manifest, sorry, custom resource definition that you saw on the previous VS Code slide is what we're going to apply here. And we can have a look to see how that's deploying. Should be quite quick. We can see it's already running there. So we can see we've got the NGINX ingress has been running for 14 seconds now, and this spins up pretty quickly, right? This plays into that auto scaling that I mentioned earlier that we'll see in a bit later. And then if we want to deploy an app here, again, I've already got the tea and coffee already deployed, so we'll just deploy that cafe one that you saw in the previous slide. So I showed all those different ones. So this cafe one. Now we'll just deploy that, and then, sorry, my Zoom window is a bit in the way here. So we have that deployed, and we can look and see that I've also already deployed a service for it. So we have a dedicated external IP. So you can see here I've used the NGINX-ingress namespace to keep this configuration separate. And we can test to see that now that we have it all deployed, I got a nice long curl statement. Is that readable? Are you guys able to see that? I know it's a bit of an eye chart. Hopefully everybody online can see it as well. But we're actually going to use that same external IP address. I've done some fanciness with the DNS so that we can call cafe.example.com. And we can see we can make a request for the tea microservice. And we can do the same thing for the coffee microservice. So we've gone through and we have, I don't know if you want to switch screens, but get rid of this. We're going to switch here, but I'm just going to do a quick summary on what we did and didn't do. So for the example there, we deployed a Kubernetes NGINX open source ingress controller environment. We deployed an application we ran through there. So it's available externally. We can access it now. It's all in a Kubernetes environment. And we've got a single pod running, being load balanced by Google's network load balancer. So that's where we're at right now with the demo. And then Sean's going to take it away with the next piece. After he jumps through the slides. I'm sorry. After he jumps through all the slides. Maybe he wants to go through them again. And we did used to work, right? When we worked together, yeah. He misses. He won't admit it, but he does.
You took your time.
Did it go way over?
No, you're right. All right. So a little bit more about Grafana Labs. So in Grafana Labs, we are a startup organization. We've grown extremely quickly. We have about 900 employees. I was joking earlier, we keep having to change these slides every couple of months. As you can see, there's a lot of installations of Grafana out there in the market from an open source perspective. But over the last 4 years, we've received over $540 million in VC funding. So, you know, we're growing, we've got some great technology. We've also got some great minds behind these technologies. So we employ about 44% of the Prometheus project maintainers. We also, part of our other products, of course, Grafana itself, we employ 100% of those maintainers. We have our products called for metrics, logs, and tracing. Logs being Loki, again, 100% of those employees are with us. Mimia, which is our metrics tool, but we call it essentially Prometheus and steroids. It's a lot more distributed. It's a lot more customizable and efficient when dealing with larger workloads inside a microservices environment. Leading contributors to Graphite and, of course, Tempo Tracing, which is our open telemetry solution that we have developed. All of these are a open source project, so do go and give it a go. Now, the reason that we have been so successful is if you've been in systems engineering for a long time, you would know what it's like to when something goes wrong. you get a whole bunch of teams, or you start opening up all these browser tabs and try and find out what's actually going on with your systems. And that's really challenging to deal with when you have so many isolated teams. So network teams may not necessarily be talking to application developers or server maintainers. A lot of these people don't even live in the same city or country. So it does become a very challenging thing to deal with. So when you have all these different systems that you are trying to make sense of what's going on inside, if there's an error, then it becomes really challenging. And that's really where Grafana excels. We don't have this philosophy that you need to bring all your information, all your data to us. Leave that data where it is, and we will plug your systems into our beautiful dashboards, and you can start to visualize them on a single screen. So it doesn't matter if you're using App Dynamics, ServiceNow, Snowflake, Spunk, there's a few examples there. It doesn't matter what you're using, you can bring it into your Grafana system and you will be able to visualize what's actually going on inside if there's a failure. So the days of having multiple tabs open and so on are very much numbered. And to talk a little bit about the Grafana stack. So we do have, a lot of people just look at us as a dashboarding tool. But there is a lot more involved with what we have. Of course, we do have our plugins where you can pull information into our system. We do have dashboards, of course. We have our alerting, which of course comes from Prometheus, or you can actually set those alerts in Grafana as well. There's a lot of reporting and also the ability to correlate your metrics, logs, and traces. So instead of having a system that does logs, a system that does traces, and a system that does logs, traces, metrics, then you can actually correlate them. So if an event happens within your metrics, you can actually relate that to an event that has happened inside a log or a trace. And you can identify within a time span exactly where an error occurred and what, really where you need to start looking to address those trouble points. We've got a lot of plugins around with NGINX. We do have a really good one, and this dashboard is actually created from NGINX logs. So NGINX does have the ability to export the logs as a JSON file. This is an out-of-the-box dashboard that you can go, once you've applied this to a log, you can start making your logs dashboards look like metrics dashboards. So it becomes very handy, and you can start introducing these on the same screens when you are introducing lots of technologies onto the one dashboard. If you want to give this a go, I do encourage you, just, I don't know if you want to take a QR code or whatever that, but if you want to run a Grafana installation and see what it looks like, clone the repo, run the Docker Compose up, go to your local host on port 3000, username and password is admin, and take it away. You'll be able to go and see what the metrics, logs, and traces, this example applications, you can see how the correlation works. It's a really easy way to get your head around what's the interface of Grafana looks like. Okay. Thanks, AJ, for this one. But if Kubernetes cluster falls over overnight, doesn't make a noise. And this is really, we'll talk about on-call in a moment, but it's really a testament as to once an ingress controller actually starts to fail and has an issue, Grafana is there to pick up pieces to start alerting people, if you know that something's going on, that something is failing, and then people can get on the calls. And I'll talk about a little bit more on call in a moment. So on-call is essentially our incident management platform. It's kind of like a PagerDuty. You can set up a series of teams and escalation paths. You can integrate it with your calendars so that if you have people that are rostered on to actually deal with incident management, they will be automatically sent the alerts whenever things are set up. So it becomes a very handy tool when you are not only you don't just have the alerts, now you have an escalation path and you can start to work through that with the teams that need to be involved. It's a really good tool. Like I use it with Slack, and the moment that you need to invite someone, you can invite them through your Slack interface. It will dial out to them on the phone and say, right, you've been asked to join a call. If there's an incident, come have a look. Then we also have K6, and we'll have a little bit of a look at K6 as well. So about a year ago, we acquired a load testing tool called K6. It's a load testing tool that was developed by developers for developers. So I don't know if you've ever used JMeter or something like that. It can get quite clunky, very memory consumption, a lot of memory consumption, and it's not really well suited to the microservices environment anymore. So K6 was designed to be a lot more microservices focused. So we'll be looking tonight at a demonstration of a load test that is distributed within a Kubernetes cluster. I'm going to rush it along because Mike's taking all my time.
I was going to say, I set up that demo the other day. It was really easy and fun to set up. And then when I broke it, because I was screwing around with it, I just called Sean. So he's going to give you his number. Yeah, if you have any problems, just for him.
Yes, so let's get into the demo because I've run out of time, but let me escape out of this. And Mike's throwing me off.
I know you missed me. You're hiding. You're hiding, but you do.
You've ruined my groove, man. All right, I just want to. Oh.
Is this working on the same example as you did?
Yes.
Yeah. Well, we built it the same way, but it's the same example. I haven't done some of the Grafana deployments. Now there is actually a GitHub repo that I'm working on for this. Let me just move this window out of the way. It's not finished, but GitHub repos are an ongoing work anyway. But we've deployed, so Mike had deployed, shown you through the manifest files. We do have Helm charts that you can deploy the community version and commercial version of Grafana and all those tools that we use. So I'm going to take you through that installation process and just sort of introduce you to where Mike left off. So the first thing I'm actually going to do is I'm going to change this up a bit, and I'm going to deploy one of the Helm charts, which is the Kubernetes Prometheus stack. This whole deployment has been designed very specifically for Kubernetes environment. And when you do deploy it, we'll start to see some stuff happening, I hope, because this is normally when things fall apart. But that's going to start to introduce the containers, pull down all the information that needs to bring up I'm not going to mess around with namespaces and so on tonight because Mike took all my time. I'm not going to let that go. All right. There we can see some of the Kubernetes components. There's the node exporters for different nodes. I'm not going to go through all the containers. It's, you can read about this more in more detail. But once this is deployed, it's going to really introduce not only an instance of Grafana or the Prometheus stack, alert managers, and so on. And then we can actually start to interact with that dashboard. I'm going to do that by using the ingress controller. The first thing I'm going to do, though, is I'm going to create the Prometheus one. Anyone here not familiar with Prometheus? All right. Okay. So Prometheus, let's see if it's running. Okay, ingress has been created. So we're using that ingress controller that I had deployed, and we're going to go to prometheus.example.com. And anyone know what I just typed there? Did I do the right one?
Well, the Prometheus is just basically pulling the metrics off the NGINX ingress controller and then converting them into metrics that we can feed in Grafana and then see visually within Grafana. So that's the main high-level purpose of that.
Grafana itself doesn't store any data, and it actually has to have an external storage, which is we're using Prometheus.
Yeah, well, Prometheus is a time series database. It stores its metrics for about 15 days. So by default, you can set those. It's very customizable as to how you set it up. It depends on how many metrics you're setting up. The performance is very much affected by how many metrics you're trying to query as well. There's a whole bunch of articles that we have around cardinality and being able to manage or streamline your Grafana installation a little bit more effectively. So I do know what I have done there. I deployed the ingress controller for Prometheus, but that Prometheus instance is not running because I'm looking at the Kubernetes cluster, not the ingress controller as yet. So if I bring this Grafana instance up, Now, because I'm using the Grafana admin, and it's from Mike, help me, what's it called again?
You're using the Grafana container
No, not the Helm chat. What was the
manifest? YAML. Sorry, I was checking to see if there's any questions online.
good move.
Wasn't paying any attention.
Prompt operator, sorry. Prometheus operator.
That was my next guess.
CRM operator. Okay. So when I deploy that that manifest, sorry, the Helm chart for the Kubernetes Prometheus, it installed this entire stack. And what we have here is we've got our alert manager, the core DNS, information around the Kubernetes API server, compute resources for the cluster. If I click into any of these, we can start to see information around the Kubernetes cluster. So that Helm chart pretty much deployed everything. I created an ingress controller, and I've got visibility across my Kubernetes cluster, different namespaces, pods, workloads, all that. Now we're not looking at the ingress controller as yet, but let me bring that into the equation. And we deploy this Prometheus instance. And this Prometheus instance is what's going to be scraping. Remember how Mike said the ports, enabled Prometheus and so on. This instance is going to start scraping that information from the ingress controller. All right, that is there. I've already got the ingress done, so this should work. For it to load up.
So is it producing a delta against the previous sample? Just being changed since last time instead of a
this is a different. This is a Prometheus instance. So the last one I did a Kubernetes one. This is just the Prometheus one, specifically for the ingress controller. I use this one because I'm very familiar with it. But you can actually start to pull that information into the same dashboards as we'll see in a moment. It's only 1 or 2 running, but let's see what happens.
So you saw in the manifest when I deployed it, I opened a port up and then I put a metrics endpoints in there. Because that's what Prometheus is doing, is scraping that particular port and that particular endpoint to pull those data off at a regular polling interval. Captures them all in the time-based database that Sean mentioned, and then Grafana will produce some really pretty graphs that your bosses likes.
Okay. Bear with me, I've just got to, sorry, it's always challenging when you start to.
The live demos are awesome.
Prometheus node, my Prometheus server, there we go. All right. So I'm just going to get that IP address for that server. Let's just see if the Prometheus instance, there we go. So that's Prometheus in a nutshell. We're not going to go into too much detail. It's got its own query language. The moment I start to type in NGINX ingress controller, we can see all these metrics already in that graph. But the Grafana instance, what we are going to do is we're going to create a new data source. Add a data source. It is a Prometheus instance. I'm just going to give it a name of NGINX IC. And fingers crossed, Mike. Love it.
So you'll see every time it queries that endpoint on the NGINX ingress controller, it actually gets a JSON payload back with all those attributes you saw listed, and then the results of each attribute. So then it can calculate, store them, time differences, all that. Grafana would take care of that. But
so there I've just gone in to explore that data source, and we can now see that all those metrics are available there. We've got a really cool metrics builder. So if you're not very familiar with the PromQL language, you can also just go to the actual code. And if you are familiar, you can start to manually type that in and create your own dashboards.
or call Sean. That's what I did.
The next step is, thanks, Mike. He's the comedian. Oh, it's just. The next step is that we do now, Grafana dashboards are all JSON files. So it's really good because it means that when you deploy applications, you can co-locate your dashboards with your code. So it becomes really suitable for those CI/CD pipelines and for automated deployments environments. I'm not doing that tonight, but I will show you what that dashboard would look like. So if I go into dashboards, I'm going to import a dashboard. You can see that I can either upload a JSON file, or I could just paste that JSON into the dashboard. Click on load. I'll just leave it in the general folder just for time reasons. We can see now that the ingress controller is up, and we've got some very basic metrics coming through. Okay. So that's now you have not only the ingress controller, you've got the actual cluster itself, you've got all those metrics that are available to you in a single dashboard. What was the next thing we're going to do, Mike?
I think we're going to make the dashboard light up with really cool traffic.
Let's give it a go.
And we're going to use a really cool open source tool, right, Sean?
I believe so. There is a very cool open source tool called Cater. Cater is essentially an auto scaling project. And I'll do the installation. I've got the Helm chart already in there. And what we'll do is we'll apply a YAML file. But before we actually apply that, we'll have a look at the contents. If we go to, no, did that scaled objects. So we'll see here that what we're going to be doing is we're going to be, we're going to be telling the Cater solution that when the Prometheus server gets this query, this is a Prometheus query, when it hits that level, which is 100, no, what was it? Over 1 minute, threshold of 10. So I've got this set to really load. So the moment that the ingress controller has more than 10 concurrent connections, it's going to start auto scaling. I'm going to auto scale this to the minimum replica amount, which is what Mike set in the ingress controller. It's at 1 replica. We've set this to a maximum of 15. Got a cooldown period, so if the traffic starts to disappear, then it'll start to cool down. It won't just terminate the moment that it stops receiving traffic. So there's quite a bit of cool stuff you can do with this Cater application.
So basically, it's producing a synthetic load onto your system, your system, so that you can get some.
No, this is dealing with the load. So this is essentially what's going to happen is we'll when we use K6 to start sending a load, then all of a sudden we're going to start seeing new ingress controllers pop up. Yes.
So CADA stands for Kubernetes Event-Driven Architecture, I think, and it's an open source platform that runs on Kubernetes, keeps track of particular metrics. So you'll see in Sean's example, it had the active connections coming out of NGINX ingress controller, and it uses those to determine when to spawn up new instances. So very event-driven. So if it goes over 10 over a minute, as you saw in the configuration, it starts spinning up another instance and another instance and another instance to help you scale out. And then that cooldown period that he showed will bring it back down once your traffic comes down to that particular level in the configuration. So it's a pretty neat tool.
So I'm just going to deploy that. And at this stage, it's just, Cater is just telling NGINX ingress controller how it's going to react if load starts coming into the application. All right.
What's really good about that tool too is when he uses K6 to send a lot of traffic, you don't see NGINX fail, which is really nice for me. I like to see that when I'm doing demos. You'll see it just grow and start taking the traffic naturally. So it's always good when you're giving demos and your product doesn't fail. So this is a good thing to have.
Okay, the next thing I'm going to do is I have got the, I've actually already downloaded the K6 operator. So I'm just going to change that directory. And we're going to do a make deploy. All right, K6 is all written in Go. Look, as mentioned, it was designed by developers for developers. So we're going to see, the cluster roles start to be introduced. So it makes it really efficient to deploy it as well. And once it's actually deployed, it doesn't actually need to be removed. You could just start to keep sending tests every time that you deploy a new namespace or deploy additional components within the. I need to get rid of the screen. Sorry.
I couldn't work out how to get rid of it either. But I'd say I did go and grab the quick start for K6, which they have on the site there, and I use it to load test a lot. So we used to use something called Siege. So it's a Apache product to send large amounts of traffic when you're demoing these types of products. And K6 was really nice because it was JavaScript, right? It was the little files that were written in.
Yes. So K6, there's a number of ways that you can use it. So the open source version is, and look, I don't want to go on about commercial products, but the open source version is you run it locally, it will just spit out a result, and then you can save those results, and then if you go. We do have, there's a cloud offering where you can actually have distributed tracing. So we have POPs around the world where you can start to send traffic to your servers, your applications, you know, and have various load points. You could have start off with 10 virtual users and really mimic some of the traffic that you've seen in your past. So it really helps you get an understanding. But having said that, the open source version is really good to give to your developers to get a litmus test. When they develop a feature, get them to test it before it even goes into testing. They've already got an idea of what the results are meant to be from that test. All right. Oh my goodness, time is running out. So I am going to go back. I'm just going to show. We have got still the Cafe application up and running. We've got the ingress controller, obviously our Prometheus nodes and so on are running. We've got the Cater operator, which is sitting there waiting for something to happen. And then we do have, we haven't deployed the K6 yet. So let me go back to this command. Right, so the first thing I'm going to do is I'm going to take this test file, and this test file is just a JavaScript file. You can record HAR files, and using your browser tools, you can record HAR files and convert them into JavaScript. There is actually a conversion tool for K6 as well. But it generally spits out a configuration which introduces the headers that were made as part of the request, the ramp up periods, and so on. So I mean, you can get very deep. I've seen some of these testing files, it's massive, or you can get very basic and simple with your tests. Now, let's get that. So what I'm going to do is I'm going to create a config map for that test file, so that the K6 instances, when they load up, they're going to know which test they're meant to be running. So I've created that config test, and next one, and I'm not going to make you sit through watching me type. So I will change this. I'm going to deploy the K6 map test, the actual K6 test. So if I go to the K6 test YAML file, we will see that it's pretty straightforward. It's looking at the config map, and it's telling you what test it's going to run. And it's going to tell you how many containers it's going to spin up on each node to run that test. Okay. So let's deploy that. And what we'll do is we'll just have a look at the pods. The next time I'll do.
Need some aliases in there.
Aliases there, yep.
So that's why I didn't take 40 minutes from a presentation. I put aliases in the demo. So quick pro tip, aliases.
No, I'll get the jobs. So these are jobs that this is going to be running. So each of those containers is going to be running on those systems, and they're going to start sending traffic according to what their test script was. And I think it was about 100 virtual users. It's going to continue, and I'll do get pods. And we'll see that those containers are spinning up. And we can also see the ingress controller spinning up as well. So if we go back to our dashboard, which is, I think it's on this tab. I think it's towards the end. And there we go. In NGINX, we can see that those ingress controllers are spinning up because they're not presenting any data yet. There is a 10-second delay for the actual Prometheus. I've not changed any of the default settings for Prometheus. So Prometheus will scrape each of these containers every 10 seconds. And as those containers start to build up and we start to see traffic come through, we can look at this graph over here. We can see that it really starts to spike up quite a lot. You can see active connections in some of them. There's some active connections coming into the second one. And if let's have a look at what the other containers, the workloads are doing. Let's go namespace pods. And we can see ingress controllers, we're just getting, they're starting to spin up, the CPU utilization, et cetera, et cetera. So that's essentially K6 doing the load test, Kata saying, right, we're getting a huge load of traffic coming through, and then going through to the dashboard, that Grafana that we created earlier for the ingress controller. And there you can see starting to deal with all the traffic coming through. Now, once K6 is finished its little testing, you can actually go into the logs of the instances to see what kind of latency and so on was. With K6, you can also do something pretty cool. If you do have a cloud account, you can actually send those metrics to the cloud account and have a history where you can actually see what's been happening in there with all the testing that's been done. And wow, it's pretty good.
I know. Well, look at that. You know that.
Was that
10 minutes for questions?
10 minutes?
Look at that. Sean just brought it back. Like I went way over, and then you just like, yeah, like Sean. Phew. Any questions for anybody virtually or in the audience? I'd like to ask some questions. We've got the Q&A open here, and I'm looking at it. I can repeat all the questions. Any of the configuration of the demo?
I've got a great question here, virtually for you.
Oh, all right. I said I didn't see a question, but
Q&A online first. Is the ingress controller different from an API gateway? And would you need an API gateway on top of an ingress controller?
why doesn't my Q&A show any questions? How is yours Q&A showing questions?
I don't know. You refresh.
All right. So I'm assuming I get to answer that one. Is that
You? Yes, you can.
All right, cool. So an ingress controller, again, just handles that north-south traffic inside and out of your cluster, right? So from the customer to the application, it's handling that traffic in and out of the cluster. So the use cases of an ingress controller can be something to just route your traffic, to do the rate limiting, to do the job validation, but all of those use cases typically are also applied to something like an API gateway, right? So maybe you want some job validation, you want to make some decisions based on claims and those JSON web tokens to determine whether a particular user is allowed to access individual endpoints. So that would be a responsibility or a use case you put in a typical API gateway. So that's something we can do in our ingress controller. So it's able to handle your web applications, your API gateways. If you want rate limiting, that's something you commonly see in API gateways. You're also able to do that in our ingress controller. So in a sense, an API gateway is one of the many use cases we can do on an ingress controller.
Yeah, it's also like NGINX is also the most widely deployed API gateway in the market. You'll find a lot of API vendors will be using NGINX as the data plane. And it does also create a bit of confusion in the market because you do have API gateway vendors that call themselves API gateways, but they're actually just behaving as an ingress controller. And we have seen this with customers where they really confuse the two terms quite a lot.
Isn't an ingress control different from an API gateway in terms of the fact the API gateway is what the ingress control actually interprets or acts on?
So an ingress controller, so our ingress controller, so the NGINX Kubernetes ingress controller is essentially an NGINX open source instance where we just added a shim that listens to the Kube API and any manifest calls you make to add apps, it's listening for specific custom resource definitions or objects, and it translates, that shim translates that request into nginx.conf code and then publishes it into the ingress gateway. So anything that any use case that you can run on an NGINX instance, so just a reverse proxy web server can all run on an ingress controller, right? So it just depends on the custom resource definition or the manifest that it gets deployed, and that's how it's configured for that use case.
Not trying to go to the point, but the API gateway gets interpreted by the ingress controller. It's the one that interprets the API gateway. Like an API gateway is like the REST API.
So it would be the front door for the data plane. Maybe you're asking about a API management solution that would take like an open API spec and convert it to nginx.conf.
Maybe I'm missing the point of all this stuff that your API gateway isn't going to just have to be up to the endpoint of the controller. That's the only thing you can do. But you can put your own custom logic into which one's going to do it.
Cool. And then let's jump to the next.
So there was is WAF part of the ingress control? I think I answered that. WAF is a additional solution. Is NGINX App Protect, which is a commercial product.
It is a commercial product and it can be installed as a part of the ingress controller. So this is not open source. So this is our NGINX App Protect offering, the dynamic module. It's been compiled to run anywhere that NGINX Plus, our commercial offering, can run. So ingress controller, standalone VM, bare metal, it can be deployed there.
It's kind of answers that question as well. Yeah.
So just real quick, regarding the access control auth WAF. So some of that is a plus only feature. Some of that is an open source feature. And if you just search for NGINX versus NGINX Plus, there's we have a great website that just has a little matrix on what is and isn't supported. So some authentication types are supported in open source. We have a lot more advanced things like advanced JOT validation, encrypted JOTs in our Plus product. The WAF is a plus feature. So yeah.
Do we need to install any other software apart from Docker or Minikube? I think that's related to the Docker Compose thing. Look, with NGINX, you'll run that on a Docker container, on a Linux binary. You can run open source on a Windows box, but you lose that multi-threading capability just because the nature of the Windows operating system. Grafana can be integrated with Apache. Yes, we do have a plugin for Apache. Grafana on-call does not have proper documentation. You're quite correct. Look, it is an open source project. Get onto our GitHub repo, start making comments, and we'll improve our documentation. The moment we start turning into a commercial, being more commercial about the ability to use on-call, that documentation will become more prevalent.
In terms of on-call, can you things like ServiceNow and all that sort of thing?
Yes, we do have webhook integration where you can actually make calls into other systems with some values. So yeah, as long as the system's able to take a webhook request, you can do that. In a multi-cluster, multi-node environment, can we put Prometheus in different nodes and Grafana in different nodes? Yes, absolutely. As long as there's network connectivity between the instances, yes, you can do that. Does NGINX ingress do a connection drain before scale down?
That's a configuration in Kata. So that Kata product, all those options there. So you saw there was a cooldown period. So you can wait until those instances come down, or you can send there's a drain function on NGINX where you can tell it to start draining connections. I actually think that's a Kubernetes feature as well.
Yes, I'm pretty sure.
Yeah.
Is it worth to have an API gateway, then to an ingress controller K8 environment for north-south traffic?
So you can combine both together, or you can run them individually. So we actually have a customer who runs an ingress controller. And remember, I talked about the personas, right? So the ingress controller was handled by the platform engineering team, but the development team wanted to handle the API gateway. So they actually ran an NGINX open source instance in a pod within their Kubernetes environment so that they could handle the API gateway portion of the use case. So they did have two of them stacked together. So it depends on your use case and your business requirements for your application.
We do see a lot of this with what's that API gateway? The big one.
The name we shall not mention.
One that we shall not mention.
Kong?
No, the other one.
The other one, Apogee?
Yes.
Apogee.
We find a lot of customers will actually augment their Apogee deployments. So because Apogee is relatively inefficient, because we'll take an API request, go back to the gateway every time. We find a lot of people that use NGINX would actually do a service-to-service call, so not actually have to go back to the Apogee deployment. It also helps saving costs. So
So the next question, NGINX Ingress, can it support blue, green, canary deployments? Yep. So you can go and configure that and weight your upstreams. So if you want 10% of your traffic to go to your V2 microservice instance and the other 90 to remain with your V1, that is a configuration option.
How much of the max HTTP requests can be handled by NGINX? Can we scale NGINX pods by monitoring transfer action specific?
So, okay, so the max HTTP request would be depending on the hardware that you define there. So you saw, and I don't know if I glazed over it quickly, but that deployment document had some resource limits and some request limits for the sizing of the pods. So you could set that bigger, but what you could also do is take that metric, and as we demoed, you could have that in your Prometheus instance, have your Kata scrape that metric, and once it gets to a certain level, that you can have your instances start to scale out with Kata. So yeah, so you can scale based on the transactions per second, but I do believe that metric is part of our commercial product, not our open source product. So that is one of the differentiations between the open source and the commercial, and that being the number of metrics we provide.
Last one, I believe, is that, yes, we did that. And the last one is, how does Prometheus scrape data from a new NGINX controllers that got created? So NGINX, every NGINX instance, Ingress controller instance that rolls up, it's exposed that information in the port 9113, was it? Yes, port 9113. Prometheus is actually doing service discovery to look for anything on that particular port. So that's how Grafana is actually picking up and going, right, there's new instances, because that Prometheus instance is basically scraping, looking for that any services that are up and running using that, and then we'll start to display that in our dashboards. 2 minutes too long then.
Oh, did you go over? So that's Sean's fault. I think that's, oh no, there's one more.
Does NGINX Ingress controller support auto service discovery, pod-to-pod connection?
Yeah, so when you define that ingress object, you saw when we defined that path in the example that I gave, I named the service. So if you have a service for your application, that service would keep track of the pods. Kubernetes would manage, of course, all your containers in your pods, and then that service would always have all the pods behind it. So that's how we identify the upstream configuration, and our NGINX Ingress controller is by the service name. So kubedns and that service name.
All right.
Cool. And then I think Cheryl said there's somebody who's gonna come off mute and ask a question. Hopefully we can hear him.
Let's see. Sure, the right audio.
Oh, and apparently I'm not on the camera. Somebody wants to look at me.
Oh.
I know. I'm so sorry.
We've muted. You should be able to speak. Oh.
Maybe they don't have a question anymore. Maybe we already answered it. While we're looking at that, I just remembered why I wore this shirt today. So another really cool open source project is NGINX Unit. It's a web application server, supports lots of different languages. So if you guys, while you're playing with Grafana and NGINX Ingress controller, you want to take a look at NGINX Unit. Maybe we'll do our next meetup with that.
Yeah,
because it's got some open telemetry.
Open telemetry, some really cool things that we could look at doing that. You should also mention your service mesh, because it is there. I like it. So.
We do have a service mesh. Yes.
All right. Well, thanks. Any questions from the room? All good. Well, thanks for your time. Question got answered.
All right.
All right. All right. Thanks for your time. I hope to see you at the next event. So I think actually there is a slide on that. Sorry. Do apologize. Where did I go with that?
Cheryl's gonna be so mad at you.
I know.
I know.
And I have to share screen.
Oh, I didn't update that photo.
All right. I do apologize. We do have another event. So do keep in touch with us. There is a virtual seminar on Wednesday, the 28th of September. I believe Cyril will be presenting on that. So if you join us, it'll be good. Open telemetry is, look, everyone's talking about it. Can be a bit of a challenge, but it's definitely worth getting into your application stacks.